Okay, I'd like to give you a short recap or review of an introduction to matter that we covered this past week in class. So we're just going to spend a few minutes reviewing the various types of matter and the way you classify them based on composition. So here in this picture, you can see there's an office space, workspace here. Everything that we see, we can touch, even things that we can't necessarily see. The air molecules around us is made of matter. Matter is anything that has mass and therefore would occupy some sort of volume, some sort of space. So it may be something like the water molecules inside this bottle or the stainless steel bottle itself, the carpet fibers here that are making up the rug, the materials used to make these golf clubs, the chair there, the wooden door, the mirror, anything that has mass occupies space, okay, has a volume, is considered matter. And so the most basic building block of matter is the atom, such as these aluminum atoms here that's making up this soda pop can. The atoms that are used to make up matter come from the periodic table of elements. So the periodic table serves as your building block system of all matter. And that may be compounds, maybe mixtures, various substances are used. Atoms are the most basic building block, okay, the fundamental building block. Examples of atoms, this is aluminum, it may be copper that's in electrical wiring and electrical circuitry, or gold that's used in jewelry, silver that's used in jewelry, something like calcium or sodium, helium, neon, something of that nature. Okay? It's one of the elements from the periodic table. All the atoms start out as elements. Okay? And then if you put atoms together, you can make what we call molecules, which are just collection of atoms that are typically held together by covalent bonds, which is a type of chemical bonding we'll discuss later in the semester. For example, this is an alcohol sample, okay? And you can see the alcohol molecules exist as a collection of atoms. You've got some carbons, you've got an oxygen, there is the red, and you've got these white representative atoms that are hydrogens. Okay? So molecules are a collection of atoms which come from the periodic table, and typically those atoms are held together by covalent bonding, where the electrons are being shared between the two atoms that are bonded together. Okay? Other examples of molecule matter are water molecules, H2O, carbon dioxide, CO2, even the O2 molecule, the oxygen molecule that our body processes and we breathe is a molecule. Okay? Sugars are molecules. Fats and oils, those are also molecules. They're a collection of atoms held together by covalent bonds. Okay? Now when we get ready to classify matter, one of the most fundamental ways to classify matter is based on its composition. And there's two main categories. There's the pure substances, which consist of just one type of atom or compound. Okay? So elements, again, are found on the periodic table. Okay, example here is these little copper shavings, copper strips here. Others would be krypton gas, argon gas that's typically found in light bulbs. Maybe zinc, a metal, or nickel metal. Something like yttrium or molybdenum. Some of the elements have unusual names, or radon gas or xenon gas, beryllium, aluminum. They're one type of atom is all you will find. That's an element, and those are found on the periodic table of the elements. Now if you take those elements, at least two different elements, it may be more than two, but at least two different, and you chemically bond them together in a fixed ratio, in a defined ratio, much like water is H2O, two hydrogens, one oxygen, that will give us compounds. Here is a picture of a sugar cube. Sugar This table sugar is C12H22O11. Every one of the little sugar molecules that are defined as sucrose sugar are C12H22O11. They have a defined composition. Those atoms are held together by chemical bonds in a fixed composition. Okay. Other examples, table salt, NaCl. Okay. Calcium chloride, CaCl2, is often used as an ice melt in the winter on sidewalks and along streets. Okay. Baking soda would be an example. It's NaHCO3. So that's its fixed composition, its ratio of atoms put together in defined composition. So that is pure substance. Now, if your matter is not a pure substance based on composition, then it's defined as a mixture, which is where you take various forms of matter and you just physically mix them together. You just stir them together, you physically mix them. They're not chemically bonded together, much like this cup of hot tea is considered a homogeneous mixture, meaning uniform composition, same composition throughout the whole cup of tea. The water molecules, the sugar molecules, and this is a caffeine molecule. They have been stirred together. They're not chemically bonded. You can see that this sugar is not chemically bonded to the water molecules, nor the caffeine molecule. They are just mixed together, but it's a uniform composition. So when you drink the cup of tea, the first sip of tea and the last sip of tea have the same uniform composition. They're a homogeneous mixture. Homogeneous mixtures are often called solutions. So when you make a solution, you're making a homogeneous mixture. You're physically mixing them together. Okay? The other type of mixture that we have is a heterogeneous mixture. And again, we're physically mixing the two together. Now, here's an example of oil floating on water. It is not evenly mixed like the cup of tea. They may separate into layers, or there may be solid particulates that settle to the bottom, just similar to fruit juice that has a lot of pulp in it, or muddy water from a pond or lake where the mud, the dirt, the sediment settles out. We often call those suspensions, okay? Or milk over time will settle, or chocolate milk. The chocolate syrup will often, if left to settle, will form a layer in the bottom of the glass. Those are heterogeneous because there is not a uniformity in the distribution of the molecules. You're going to see layers, or you're going to see clumps, lumps. You're going to see varying compositions, much like a fruit salad or a vegetable salad. You're just mixing those together, tossing them. There's not a uniformity to the whole sample of matter. Okay? So mixtures, we have physical mixing of the matter. Pure substances, we have purity, a single type of atom, single type of element present. Compounds, two or more elements chemically combined in a fixed composition. Okay? I hope this gives you a quick review, summation, and maybe clears up some confusion with matter and the classification of matter based on its composition.